Okay, we're in section 12 now, and it's really kind of like a infinite loop. It's not infinite though. It's going to stop at exercise 139, and there's some appendices to go through, but we'll get there. And again, I want to warn you, the beginning part for some students might seem like a little bit of review, some new stuff on it. It does get more and more difficult as time goes on though. All right, so we're in section 12. My name is Ron Bannon. This is a draft version. It's basically a rewrite of an algebra course I was taught back in 1904. I'm certainly adding a lot to it. At least I believe I'm adding a lot to it. Certainly page count, I'm adding a lot to the project. Each section you're going to see contents. Each section you're going to see examples. Each section you see exercises. I would say read through the content, try to understand the examples, and then reinforce what you learned by doing exercise. It's a lot of work though, all right? If you do need to reach out to me, my name is Ron Bannon. My email address is Bannon, that's B as in boy, ANNON.US. All right, let's scroll through. Let's take a look what this looks like. And, for 12, they're saying that, basically you're going to be factoring. Well, I've been factoring for a while now. And they're saying one type of factorization you're going to see is what's called the difference of perfect squares. All right, so we'll go through that. That's one thing at a time. All right, so I want to write down what they're looking for. They're looking for a pattern now. And the pattern they're looking for is a squared minus b squared. This is a very simple pattern here. A minus b, a plus b. So the first thing I want to get across to you is that these are perfect squares. So it's going to be 6a b squared, quantity squared, minus 7c cubed squared. Well, let's write this down now. 6a b squared minus 7c cubed times 6ab squared plus 7c cubed. Look at the key and make sure you're looking at that. And I really do mean that. Make sure you're looking at the same thing we say it should be. Now, granted, if you think I made a mistake, bring it to our attention and we'll go through that. All right, so over here I'm looking at it. I'm saying this looks like the a minus b, a plus b. Let's write this over here, and I'll be careful about it. So it's this thing here minus this thing times this thing plus the other thing. Now somebody say I'm done with it, and I'm not saying you're not done with it, but I think there's something we probably could do with that. And what could you do with that? You could, combine terms. And let's look at the first factor. It contains a bunch of terms. 2x minus x is x, minus 3y, minus a minus y is going to be minus 2y. I just did this thing over here. Now let's do the next guy. I want to see 2x plus x is 3x. Minus 3y minus y is minus 4y. And we're done. That's a better answer, by the way. That answers what we're staring at right over here. By the way, both answers are being listed for, but this one is very busy looking. The final answer is really nice. X minus 2y times 3x minus 4y. Let's look at the next one. And again, for a lot of students who look at this, they just don't see it, right? They don't see it. So my goal over here is to claim to you that probably if you rearranged it, maybe you would see it. But I'm not going to say you're always going to see it. You might say, no, I can't see that. Well, look around. Look around. So what am I doing over here? I'm looking at this, and I'm looking at it. It looks really bizarre to me. But really, what am I looking for? I'm looking for something. I'm looking for a pattern. And someone said, I have no idea what pattern you're looking for. We're looking for this pattern. So I only see one minus sign over there, and let me write this down for you. And what do I see? I see, and I'll write it down for you. I see 2mn plus m squared plus n squared minus 1. I got another problem on hand. And the problem on hand now is I'm looking at this thing here, and I'm wondering, what is that thing? And if it's anything, it's got to be a perfect square. Well, let me see if I can do that. And I'll do it by rearranging it. All right, so I'll write it down as n squared plus 2mn plus m squared. Now, by the way, someone says a lot of rearranging. It really is. But this first term I'm seeing is really just n plus m quantity squared minus 1. And 1 is a perfect square. Let's put it as a perfect square now. So what do you get? N plus m minus 1 times n plus m plus 1. And there's not much we can do about that. Again, look at the answer key to make sure you're in agreement with what's being presented to you. Okay, that's done. Let's do this. And again, I'm starting to say, well, maybe it's the same problem. Let me rearrange it. All right, so I'll do that for you. As I do that, I'm looking at, I don't know, I'm looking around. And, it certainly says, why do you have to look around? I can't say it's always going to be, like, simple to look, but I'm seeing something. I think I'm seeing something anyway. And what am I seeing? Let's take a look at that. I'm seeing, let's see, x squared. That's a perfect square, right? Let me write this down now. Minus 9y squared. Writing that down. Plus 12y. And then minus 4. And again, my goal is I'm hoping to see a squared minus b squared. Not seeing it. Let's keep going. So I'm going to write x squared minus, I'm going to put this in parentheses now, hoping it's a square. That would be 9y squared minus 12y plus 4. Now the question is that a perfect square? Well, let's take a look. X squared minus, well, it looks like 3y minus 2 quantity squared. If you're a doubting Thomas, I want to point out to you, you should do this. 3y minus 2, squared means 3y minus 2, 3y minus 2, and that's going to be 9y squared minus 6y plus 4. And do we get what they said? Yeah, you get what they said. 9y squared minus 12y plus 4. Let me get my eraser. And again, that's to satisfy the doubting Thomas that say, oh, gee, I wonder why that worked. Let's write down we have an answer now. And again, I'm looking at this. X, minus, all right, let's not get too tricky here. 3y minus 2 is plus 2. And then it's going to be x plus that, plus 3y minus 2. Again, if you're doubting Thomas, multiply it out. You'll see this. Let's get the key. Am I seeing that? I am seeing that. And that's good news for me. All right, let's go to the next one. Hey, there is no next one. So what do? Go to the exercises, work through them. They're really not that bad. You're going to see some things over here. I want to point out the things you're going to be seeing. You're going to see a squared minus b squared, which is a minus b, a plus b. That's one thing you're going to see. Another thing you're going to see is probably a plus b squared, which is a squared plus 2ab plus b squared. That's a perfect square. A minus b squared, which will be a squared minus 2ab plus b squared. You'll be seeing these three patterns. And by the way, they're really important patterns to be looking for. Look around for them. You're going to see them, right? You'll see them in abundance. Related Sage code. Again, I know I say this a lot to you. If you have access to a computer algebra system, that's great. I do recommend Sage. Reason being, it's used all over the world. And yeah, it's free. That's a good thing, right? Now, when I say it's free, it's really not free. People work on it. They put a lot of time and effort into it. And if you can contribute to that project, you should. All right? I contribute to them. I contribute to it also by supporting it, by getting other people to use it. So it's really a large community. Certainly when you go to the website, you can download the application or use the interactive web-based application. And then, run some code over here. As you're running code, though, look at it. Try to understand why we're doing this code for this particular section. And we're hoping it's starting to make sense to you while we're going through that. All right? Just an introduction. That's all we're doing. Thank you so much for paying attention. and we'll keep moving forward. Thank you.